Okay, well, then let's move on to our last two. And John and Chris, we spoke yesterday, and it was originally going to be, I think, just a 5 minute call to just kind of sort out what we were going to do. And then it ended up being, I think, an hour and a half because we just got going and going and going because these are two men that are working on solutions. I'm going to just summarize what we have now. What we've been talking about now is what we've had and what has been developed and has already been implemented and has been shown to work, and hasn't been embraced maybe by the industry as much as it is will be now because we need to use it. But there's always been limitations, and that major limitation has been the brick wall that we have with latency. And technology just isn't there yet in order to enable us to have the immediacy that we need, or is it? And that is with the conversation with John and with Chris. So the two of you, John, you have a project that you've been working on, and Chris, and I know. Do you want to have a conversation much like we did yesterday afternoon, or Chris, do you want to do a presentation, and John, do you want to do a presentation? How would you like to handle this?
Flip a coin continentally here.
Yeah, I would love to hear, Chris. Obviously, we're coming at things from different angles, but certainly from the technology standpoint, you have done some pretty incredible things already. And yeah, take it away.
Okay, yeah, then happy to, and can't wait to hear what some more from the beginning of our discussion yesterday too. So yeah, thanks for having me, an interloper from the West Coast at this point. And also towards the end of all these brilliant discussions and presentations, it's a wonderful position to be in because all of the problems have been so well laid out there, pitfalls and motivations in particular. So we're in this changed era. The circumstance we're in has meant that something from my life that started out as a garage project years ago, and kind of a fascination in experimental music, now has a bit of utility for a whole bunch of people who find themselves musically distanced because they're socially distanced. I'm going to share a screen if Zoom will allow that function from here, and just show you a bit of a slide deck that's part of a course that I started for 3.5 weeks ago, and the course was intended as kind of an emergency thing with the onset of a new spring term at Stanford, completely online, and exactly as we heard from others, particularly U of T and Eastman, our ensembles at Stanford have been basically out of business. And so I kind of put together something with a just very strategic thing in mind, where I would muster some people who are trained on the technical side, called the Internet Ensemble Tech Force. That would be this class, and then we would do our best to support ensembles playing together online, and locally that would be kind of ranging across the entire gamut of musical activities at the Stanford Music Department, but also worldwide. And we're in week 4 right now. It seems to be working out pretty well, and the the boundaries around this has a lot to do with just what's available to people from their home networking. I'll show you kind of the intro about what you would need, and we were talking only about small groups. The larger ensembles and the conducted ensembles are kind of like outside of what we can do right now. But using, laptops and desktops, even small computers like Raspberry Pi, if you have a home network that is, like mine is modestly capable. I don't have anything near what, some of my neighbors in Silicon Valley have. So I'm on a cable subscription, and I can do stereo audio now from home, uncompressed at very high resolution. And I couldn't do that 5 years ago when I started from the same location. We don't use Wi-Fi just because there's a bit of a fallibility in the way Wi-Fi manages a continuous stream compared to the kind of stream that we're trying to do. We don't use built-in sound if we can avoid it. So, plug in a good audio interface, and the better it is and the better the microphone, the better the result. No surprise. We are really just talking about audio. The video is usually a side-by-side channel like Zoom or one of the lookalikes, and we're not going to ever pretend to be able to do conducted video. At this point, the ironic thing that we know about streaming on the internet is that we can get uncompressed audio through in a GIF where anything that we do with video is laggy, and so it's always a case of this thing that's reversed from the physical world. In the physical world, a conductor conducts, and somebody 100 yards away on the football field in the marching band gets the cue. And that's sort of our traditional world of synchronization by conductor. Well, on the network, it's flipped around. The audio gets there before the video. And sadly, I can't join you in the pre-meeting COVID drinks. We just haven't figured out any of that side of this yet. There are a couple of courses if you're interested in this. There's a course on the Cadenza platform. I think it's the next slide here. Yeah. This is a MOOC or a massive online course type thing, which is 2 years old now. So you can go to this MOOC, do it for free. It's about 6 weeks worth of sessions, and you'll go through the technology and some of the history and successes and challenges of doing uncompressed audio over IP on wide area networks. That's the content. So this present course that I'm doing skips all that. It's about just crash course, getting the help up so that people are trained and ready to jump in and help an ensemble do what they want to do. Maybe they're a member of the ensemble too, but often there's, a lot of detail work that needs to be handled by someone who's motivated to do that, has, done a bit of the preparation and can help the others go online. So where we are, let's see, I'm just gonna scroll down the deck. This is a living syllabus. Every week it gets a new chunk of stuff.
And this is all on your website.
Yeah, you can get it here. So we've learned so much in 3 weeks. One of the things I learned was if I put a server up in listening mode that can handle connections from independent houses away on the network somewhere out there in the cloud, people connect in. I just sort of boastfully said, yeah, we'll probably be able to do a dozen. And then when we got to that point in the course where I'd have everybody pile on together and then we just pool all our audio, I couldn't cut past 8. And it's seriously the case that we're trying stuff now that we, through the years of being in this medium, we had never pushed to some of these extents. So here's a test of a server that has the solution. It turns out that this thing has 16 cores, and we were able to do 16 connections to it. The limitation that we never knew before was that in the code we're using, there's an ideal number of threads that can run, each thread being one of our connected clients. And we now know. So we'll probably change the code. But I was kind of proud of this macrame picture that was automatically generated when all 16 piled on. And the patch has all signals going to all places. So you hear your loopback and you hear all of the group. So without any more screen sharing, let's flip back, and I'll sort of tell you what I think is coming next in this. Is that first of all, we've learned, as I said, a fabulous amount of what the hangups are and the pitfalls for different operating systems, different levels of sort of audio sensitivity about, like, how well your microphone should be cared for, gain wise. What about the connectivity that's available at home? What are the pitfalls in terms of firewalls and all of that stuff that we sort of knew, but when you pile on, just like that server, when you have a whole bunch of people doing it together, it starts to categorize where the pitfalls are. So I'm taking the information gained from this and I won't call it an exercise, this emergency, and I'm shoveling that into a new course, which is going to be like a 4-hour how-to. Here's the open source software. Here's the hardware that has a lot of choices, and here's what you probably need to be able to come up with in terms of home networking in order to pull this off. The other thing I think that has really emerged in the last days, and I'm really speaking about daily discoveries, is that the original conception of JackTrip, which was basically a telephone, it was a server here and a client over here connects, and you have bidirectional audio streaming uncompressed. It's a really simple picture. And the win-win is that we're doing uncompressed audio, so we don't have to wait for coding and decoding or codecs to do their bit. And it's a win because it sounds good. If the network's up to it, you get that connection. If it's a very well-provisioned network, like we have the advantage of working with at large labs and universities, between places like that, it's phenomenal because you get the connectivity established and you can just ramp up the number of channels. The demands that we make on fiber networks in audio are barely lighting up the graph. Whereas, uncompressed video, that's a whole nother world. But we can go to 100 channels and things just hum along nicely. In fact, we don't even get noticed. And I'll say that invented in Canada, it is. I did this work at the Banff Center over the course of a number of years. And my favorite sort of push on that number of channels was a concert that we did with Humber in the recording and jazz faculty at Humber College with Dave Douglas's jazz workshop at the Banff Center. I think it was like 2010 when we did this one. And we had 16 channels going each way. It was a split big band. On each side, they were tracking 32 channels. So the outgoing 16 and the incoming 16. So we had two sets of the same concert, two different perspectives. And what's available on my website is a stereo mix that was just somebody's then rendition of this event. How would you put together something like that? We probably had about a 35 millisecond one-way audio to audio, and that's pretty darn good for 3,000 kilometers. So with our musicians, who were kind of the astronauts for this event, there was a bit of there was a bit of hesitation, which is a funny word to use when you're talking about lag. But some of the players were just saying, there's going to be lag. This is never going to work. And indeed, the rehearsal was kind of a mess because there was a lot of skepticism. I had skepticism. The concert the next day is what you hear on the mastered version, and it's just an absolutely gorgeous performance by 16 musicians separated by 3,000 miles, full on audio. And we were using the Canary network. So again, the position we're in today is that we're doing this from home. I have to open my buffer sizes to something 10 times what it would have been when I was on the Canary network. So 1024 audio samples is very common for the home experiments. 128 samples is very common for well-provisioned fiber networks. But colleagues, like I said, have fiber to the home, and they're down to that level now too. I wish I could get it up here in the woods where I live. That's going to happen someday. But I'd say that the takeaway is that the combination of ingredients is there to do this from home. We're going to be doing it for a while. I'm afraid we're in the same boat everybody's describing about, uncertainty towards the upcoming academic year, particularly in terms of academic mission. We don't know if we're going to have ensembles probably not practicing together by September yet. So this is kind of how this project is going to have to keep going on my part, with a lot of colleagues who are helping with it, students who are trained on it now, worldwide, a whole bunch of practitioners. And the best part of this is with all of this kind of new context, I'm getting a lot of contribution of code into the project. So it's open source, it's free, it's a community software project. It's got all the warts that everybody knows about JackTrip, but it's getting better in terms of installation. So, stay tuned. I think, bit by bit, it becomes more and more streamlined. And, just to close, it's a vehicle to do something that humans like to do and that networks seemingly aren't really adapted to, as we've heard from others. We like to synchronize. We like to be together, and whether that's music, dance, theater. I was just talking to somebody in theater production today about rhythm in the sound and the visuals of theater and how they're challenged just in the same way we are. But real-time networks are there, and we have one of the best, most definitive use cases for real-time networks in music. We make demands on this that you can only sort of find equivalent in 3 other categories, and I'll just say that we're in interesting company because there's music collaboration at low latency. There is telesurgery, where you need to have absolutely high fidelity reactivity in order to remotely operate a scalpel, for example. In high frequency financial trading, milliseconds count, and a lot of engineering that's going into fiber networks is actually motivated by that sort of cost equation for financial trading. And then finally, it's the world of gaming, that interaction in games with groups is also another driving factor. So now I'm looking forward to hearing from John and his project, which is in the same space.
And before you do, Chris, I'm wondering how much you can speak towards the issues of packet loss. I mean, this is a technical term, but which we're all familiar with, and that is once you start streaming and you get going through different servers and different switches, the information doesn't stay intact. You have a solution that you are working on, which is going to resolve that. And then the second thing, which I'm pretty sure you said you were able to talk about, is that you sabbaticaled in Europe as a skeptic initially, because he had been invited over because they had to put basically artificial intelligence that's going to be able to assist music and assist some of the problems that we're experiencing here. He went over to the skeptics and there's no way this is going to work. He came back a true believer, and we're now and that is on a workbench someplace. And these are the things that I'm really perking my ears up on, because I know that it's not going to be years. It might not be weeks, it may be months, but it is imminent. these types of things. So is it, can you briefly summarize, or have I said everything that could be said about that?
No, you just said it really well, but yeah, maybe just to add a little more from what I've learned. There are, two kind of dirty little secrets in the streaming business that we're talking about here. When you engineer audio over best effort networks, well, best effort is what it says. Maybe the effort isn't gonna, you're gonna succumb to losing packets every once in a while because of connectivity. The other side of that is you're gonna lose packets. You're gonna guarantee that you lose packets because we're talking about sample clocks that are at different places, and there's no word clock, synchronizing to devices. Over this time that I spent in the winter in Europe, both of those were kind of projects that we were trying to improve on. So starting the other way around, I'd say the sample clock problem is actually solvable with GPS time from the satellites. So we had a wonderful demonstration of that by January between Berlin and Edinburgh, Scotland. So both of our sound cards were looking up in the sky, getting the same clock, and we were locked at 48 kilohertz. And in JackTrip, I can see when that horse race is getting to the point where it drops a packet, and we were locked. It was even. So that's a huge, wonderful win, I think. Paul Ferguson at Napier Edinburgh University. The second is what Earl was just talking about. Maybe there's some tricky stuff you can do to do better error concealment than current software does. In JackTrip, okay, again, sort of revealing all the warts, JackTrip by default just says, oh, I don't have a packet in time. Let me just repeat the last packet that I had that was a good one. And so repeat. What does that sound like? Sounds like a vocoder. So anybody who uses JackTrip on a lossy network is used to that. You can put in a switch in the command line that says 0, which will just mute it. So take your pick. Do you want mute or do you want a wavetable? There's something better. And working with Dr. Cristina Rotondi at the Politecnico di Torino. So she's a professor of telecommunications and a singer, and had the idea that maybe machine learning, sort of an artificial intelligence approach where you take a machine, you train the algorithm on patterns, and then once it's successfully trained on lots and lots of data, you're in a space where if that pattern is violated, you can predict what it should have been. So question number one, does machine learning even do something useful for short gaps, little missing packets of musical data? Answer is yes. And it was beautiful to see the result. Number two, can you do it in real time? How long does it take to make that prediction? Can it be done in time to cover for the missing data? And number two, yes, real time, because it turns out to be extremely efficient. Except for the need to train the system. And that's where we're back on the lab bench right now. And training is something we're learning a lot more about, and how to generalize the training so you don't have to ask your band to do a sound check that takes 8 hours so you get enough trained data about how they play. You don't want that. So short of that, there's another trick that is an autocorrelation based trick that we're going to put into JackTrip shortly. That's actually being worked on. So it's an alternative to machine learning, and it actually came to our next method as a result of comparing classic versus new. And turns out autoregressive filter prediction is very classic. It turned out it worked really well. So that's going into JackTrip as soon as it goes into JackTrip, which is soon, I hope. So yeah. Anyway, that's what we were working on there.
there's an easy way to describe that. It's except for, when I hear that, that to me is just revolutionary. Maybe I'm overseeing something, maybe, but I'm seeing it's in the infancy. This is something that's just going to grow and grow, because I think no matter what we deal with, there's always going to be the issue of packets getting lost, no matter how stable a system, because it's just the reality of the world that there's other competing interests. And so for something like that, and the notion of the big clock in the sky, the big GPS wheel that enables disparate, or disparate's not the right word, different regions be able to perform together.